Okay, so I'm going to demonstrate to you today a beginning project for monitoring the internals of a Hive electronically. This is a sort of prototype box using a Node MCU controller. I've got an environmental sensor there, the idea being this could be fitted into the crown board of the Hive. It could be a lot smaller. This is the main intelligence of the beast. The rest is around some power supply and making it easier to break out to the pins. So we'll see that again in a minute. I have another one here on the breadboard so you can see more clearly the environmental sensor. I've got a power LED, and this lead will be explained to you a bit later on. That's going to connect to my PC through this power monitoring adapter so we can see what's what. When it's running, we'll see on this here what's happening on the actual node controller, and I'll be able to explain that to you. And that will be sending over the Wi-Fi Internet of Things protocol messages to this Raspberry Pi sitting here on the Wi-Fi. And then I'm remotely monitoring that with this MQTT spy program, which allows me to eavesdrop on the Internet of Things messages. So what we'll see going on there is the messages and the topics coming in, which would normally be imported into a database or published to a website. Okay, so let's power this thing on. You'll see here as I plug it in, we'll get a voltage monitoring going on, but I need to connect this so you have time to see it. So let's give it a reset. There we go, that's already come through with one set of messages, because in the time it takes me to get the screen monitoring active, you'll see it's there. So here's my temperature and humidity information and an IP address. If we look on our Internet of Things broker subscriptions, I've got two topics. The serial number here is the serial number of the device, and so that's our Hive number effectively, and I'm currently monitoring temperature and humidity, but looking at also finding a way of doing it with maybe weight as well. We're just starting another cycle, so we'll watch this come in. You'll see the time change as the messages increment from 1 to 2, and there we go. So that's another cycle. Currently this is set up to reboot every 30 seconds. In reality, I probably do it once every hour or half an hour. I'm now going to connect this lead to ground, which is simulating an effect I will have where there may be a photocell in the roof of the Hive, and this would mean that every time the lid is removed, it would detect it, and then it would send a message rather than just the environmental information. So we see it booting up again now. Also, of course, the Hive roof detector would wake it up from its sleep mode, so it wouldn't have to wait to the next half-hour cycle. So you can see that it says Hive roof removed. So this obviously could be sending a text message to me, as well as entering in the database. So if the Hive monitoring was asleep for an hour and this was lifted, it would immediately wake it up and send a message. And here we can see the power consumption, currently 0 as each cycle starts. We're just about to boot up again. You'll see it take about 50 milliamps, sorry. And at the moment it runs for about 8 or 10 seconds, I think, per cycle. So it's gone off again now. So if we only drew that much once every hour or half hour, we could get quite a long battery life, but we could supplement it from a solar cell. Okay, that's the end of today's demo.